Okay, so here we go with the what I consider the best explanation of my approach to printing this cylinder head development Flowbench model. Right here is basically a piece of glass off of the build plate of my 3D printer, and so everything that prints in layers, all starting with the build plate. And so to demonstrate how the printer works, I'm going to use this as an example of how the printer works. So the print nozzle where the plastic comes out would be right here, and so on the printer itself the nozzle goes back and forth like this, and the table moves in and out, essentially moving like that. And so everything that you print is going to be parallel to this build plate table. And so as we look at this model, one of the difficulties of this whole thing is that the valve angles are not parallel to the Flowbench surface. And to complicate things a little further, the intake valve and exhaust valve are not on the same angle. And so to best illustrate what happens if you don't separate these things and make the valve seat parallel to the build table, like I've done there, is this piece here. And so it was printed flat like that. And so if you have a surface that is not parallel to the build table, it essentially gives you this type of a finish. And so if you would consider this stepped finish all the way around the valve seat like this and the valve guide, there's no real way to make everything really fit where the valve's going to move in and out, and the airflow is going to come between the seat and the valve itself. And so what I did was go in and separate all the right planes for the valve seat on the exhaust side, the valve seat on the intake side, and then figure out the best method I could to make everything register to each other. And so we'll start off with the bottom piece. And so this printed just like that, or basically like that on the build plate. So this is the side that will go down against the Flowbench right here. And so what we have here is the very beginning of the combustion chamber on this side, and the reason it's there is so that I can create a register for the intake and exhaust portion of the chamber to sit flat against and register around the edges. And so this piece coincides with this piece, and both pieces have dowel holes, and so when everything goes together they'll be doweled together, it'll all line up perfectly. And so this was the bottom plate, this is the intake portion of it. And so as you can see, it was printed flat, and you can see how nice and shiny that is. It's basically against the glass, it puts a glass-like finish on it. And so it sits against the glass, the printer comes in, prints circularly, everything ends up concentric to the valve guide and the other parts that go together. We did the same thing on the exhaust side. So these two pieces actually go together, but as you can see here, they're at two different angles. And so printed flat, keep the seats concentric, but in order to go together they have to mate up like that. And so if you look at these pieces roughly like that, you can kind of see the difference in the angles. They're also compounded the other direction, and so hopefully you can see all that. And so how this ends up working is that this piece is like that. The intake side sits down in this pocket, pushes down in, registers against the edge. Exhaust side does the same thing. And so it comes in here, fits down in there, really tight fit, registers in there, and those pieces will all be glued together, but you can see they come in and basically form the shape of the chamber. Again, this is the side that goes down against Flowbench. And so those pieces are a combination they end up underneath here. They fit up against the actual areas that go up next to here. These pieces fit down inside of here. This has a register down in here. These pieces also have a register around the outside edge for that one, around here for this one. And so when they fit together, this is all one print. This is basically part of the intake runner. And so how this works is, this is the outer face of the intake runner. It has two dowels on it. This is the entrance of the intake runner. It has a nice radius built into it, also doweled. And so these two pieces fit together. Basically like that. And I don't know if you can see down in there, but maybe this direction. So with the dowels, this piece will all fit together. It will have a nice shot on the runner. This portion fits up in here. And right now, part of what I'm using this glass for is, since it's perfectly flat, I can lay a piece of sandpaper on there, and where the intake and exhaust side come together, basically like that, and then we have the intake side like that, where these two pieces come together, because of the layers of the 3D printer, it leaves a not a bad finish, but it's a slightly coarse finish. And so I'll lay this sandpaper on this perfectly flat piece of glass, set the parts on there, and just sand them. Sand them in all different directions. And so basically we just take that somewhat rough surface, knock the peaks off of it, and we'll come back in and touch up the dowel holes, and we make this thing so it'll fit together really nicely. This intake side, I'll show you an example of how this works. Like I say, we had a register here and a register here. This piece goes up in there. As you can see, it fits pretty tight. We set that down up in there. And you kind of see how all this fits together in there. The exhaust portion of it fits the same way. I'm not going to push it all the way down in because it is really tight and it's hard to get back apart, but you can see how these pieces will eventually fit together. This one sits up against here. This will match up with that. The ports will align. Same thing on the inside of here. There's a port in there. When that's up, that'll all align. And then once all that's in place, this will sit down on there in this direction. The exhaust will line up there, the intake will line up there. And so that's kind of an overview of how everything is going together, and so we'll keep sanding on this stuff, get everything fitted really nicely, and then dowel and glue it all together.